Assalamualaikum to everyone. I'm Nobalkis Mintu Zulkifli. We'll discuss about question 10. My question is calculate the pressure in tank A as shown in figure 4.17 and account for all minor losses. In this equation, is given velocity in reservoir, which is VB, is equal to 0. Pressure in at reservoir, which is PB, is equal to 0. And velocity at reservoir A, which is VA, is equal to 0. So that the equation required HL and the pressure at tank A. Then, first step, by using energy equation, we know how to calculate pressure A. So, the equation is EA minus HL equal to EB. EA is equal to ZA plus HA plus VA square over 2G minus HL equal to EB, which is ZB plus HB plus VB square over 2G. Then after that, HL will transfer to the right side. Then VA equal to VV because of the diameter not change. PB equals to 0 because of open to atmosphere. After that, we conclude the equation as ZA plus HA equal to ZB plus HL. We know that HA is equals to PA over specific weight. Then we calculate PA using this equation, which is PA equals to specific weight times ZB minus ZA plus HL. Then step 2. Step 2, we must calculate H loss to find pressure A. So head loss or HL is equals to H1 plus H2 plus H3 plus H4 plus H5 plus H6. H1 is entrance loss, H2 is angle valve, H3 is swing valve, H4 is friction, H5 is elbow, H6 is exit entrance. So this is angle valve, this is swing type check valve. So this is the pressure at tank A that must we calculate. So from what I said, HL is equal to H1 plus H2 plus H3 plus H4 plus H5 plus H6. Then after put the value, we get the HL, which is HL equals to HV times 7.32 plus 724 times friction factor. Then step 3, HL cannot be calculated because we did not know HV and friction factor. So from 2 p.m. schedule for this steel pipe, we know FR is 0.019 and the formula of HV is V square over 2G from the 1M pipe. Then at first, we calculate the velocity using formula Q equals to AV. Then we know that V equals to Q over A and get the 3.344 M over S. Next, the value of HV can be observed, which is 0.57 M. Step 4. To find friction factor, we must know the Reynolds number and relative roughness. This is the formula of Reynolds number, which is V times D times density over viscosity, and get 8.47 times 10 the power of 4. Next, relative roughness is elasticity over diameter. So we get the value which is 0.000876. The elasticity is 4.6 times 10 the power of minus 5, and density we know that 0.0525. So we get the value. Then after we get the Reynolds number and relative roughness, we can get the friction factor from the Modi diagram. So the friction factor from this question is F equals to 0.022. Then lastly, we can calculate the pressure at tank A after we find out the HL. So then the final answer is 143.5 kPa. So this is the equation, then the answer. Okay, that's all. Thank you.